Everyone. Today we are going to continue with our discussion of graphing transformations of sine and cosine functions. But this time around, we are going to be working with a value of a that is going to be negative. So far, every single trigonometric equation that we've dealt with has had an a value that's positive. So what happens when our a value is negative? Well, just like with any other function that we've worked with, a negative a value has always indicated a reflection across the x-axis. And that is exactly what is going to happen here. Our graphs are going to be a reflection of what they used to be. So in this picture, what you see here is y equals negative sine of x. And we know that the pattern for sine was always 0 up, 0 down, 0. But now look at this. It's now going 0 down, 0 up, 0. So it has been reflected. Our wave has flipped compared to what it usually does. So it's a reflection. So notice that these two graphs, even with cosine, this is a cosine function with a negative a value. Normally cosine starts up here at 1 and it goes 1, 0 down, 0 up. Instead, this time we have 0. So we start down here at -1. So down, 0, up, 0, down. So it's the complete opposite language of what we are used to. And instead, this is simply a reflection of notice that they are reflections of the original graphs of y equals the sine of theta and y equals the cosine of theta. So these are reflections, and I'm going to say across the x-axis of what we are used to. So what I'm going to write down for you is in words what the changes are for when you have a negative a value. So notice with sine, we're still starting at 0, 0, but instead of going up, when you have a negative a value, you go down to your negative a value, and then back to 0, then up to your positive a value, and then back to 0. So 0 down, 0 up, 0. And I'm going to write this down on the side over here. So if you have a sine value or a sine function with a negative a, you're going to be working with the pattern for each cycle being 0 down, 0 up, 0. So 0 down, 0 up, 0. Cosine is going to be the opposite language as well. So notice that this time we're starting down at 0a, back to 0, up to a, back to 0, and then down to negative a. So down 0, up 0, down. So that is what the pattern is for cosine. So a cosine with a negative a value follows the pattern of down, 0, up, 0, down. These patterns, I strongly recommend that you study them and know when and how to use them. This might be something that you keep close to you whenever you are making decisions about how you're going to graph sine and cosine. Are we going 0 up? Are we going 0 down? Are we starting down and then going up, or down? Or are we starting up and then going down with respect to cosine? All right, so let's go ahead and see how we're supposed to graph. So as you guys saw, I have a highlighter. I'm going to strongly recommend that you have a highlighter as well for today. If you don't, just any other color will be certainly helpful as you are creating your axes. So looking at this graph, just like we always do, we identify our a value first. So this is a equals -2. Our b value is 2. Our h value is going to be pi over 4, and our k value is 2. My amplitude, remember amplitude is always positive, so I'm going to take the absolute value of -2, and that's going to give me +2. So my amplitude is the number 2. Period is 2 pi divided by our b value. Our b value is 2. The 2's will cancel away, leaving us with pi. My axis is still going to be based on y equals k, so that's y equals 2, and I always graph that right away. Oh, excuse me, we're going up to 2. Sorry, I got too excited. Going up here. Ignore the other dashed line. So this is y equals 2. All right, so now we want to find the 5 key points of, and this is going to be y equals -2 times the cosine of 2x. So yes, we do include the negative, and we do include the, so that full a value and b value, but we don't use h and k for when we're coming up with the 5 key points of. So notice that this is, once again, without h and k. And we do use the negative a value and our b value, basically just like normal. So now this is cosine, and cosine always starts at 0a, and my a value is -2. So we're starting at 0, -2, and that is down. So we're starting down. And then to come up with my x values, we're using the same steps as before. We're going to multiply 1/4 times pi, and that's going to give us pi over 4. And there are a couple of approaches for coming up with your x values. This pi over 4 represents your increments that we are adding each time to get to the next x value. So this is pi over 4. The next one will be 2 pi's over 4, which simplifies to pi over 2. The next one will be 3 pi's over 4. And finally, 4 pi's over 4, which simplifies to pi. We come up with these values by multiplying 1/2 times pi, or sorry, 1/4 times pi, 1/2 times pi, 3/4 times pi, and 1 times pi. Both approaches will still get you the same exact values in your x values of your table. The y values follow that pattern. So because our a value is negative, we're going to follow the pattern of down and then to 0, up to +2, back to 0, and down to -2. So we're following that pattern of down 0, up 0, down. Remember, we do not graph or plot the points from this first table. Instead, we use that first table to help us come up with our final 5 key points. The other thing that helps us is the second x value. That second x value tells you the increments that you're going to use on your x-axis. Okay, but don't put those in yet until you come up with your final 5 key points. Our translation vector this time is going to be pi over 4 and 2, and I'm going to put little plus signs in front of them because this tells me that I'm going to be adding pi over 4 to all x values, and I'm going to add 2 to all y values. So now we want to find the final key points. So I'm going to add pi over 4 to my x values. So that is 0 plus pi over 4, which is going to give me pi over 4. Pi over 4 plus pi over 4, that's 2 pi over 4, which is pi over 2. And if you guys notice that we're just adding a pi over 4 each time to get to the next number because the spacing in between our x values doesn't get bigger or smaller, we're just shifting the graph over pi over 4 units. So that's 1 pi over 4, 2 pi's over 4. The next one's going to be 3 pi over 4, 4 pi's over 4, which is pi, and 5 pi's over 4. If you want, you can just simply add. Like this is pi over 2 plus pi over 4 will give you 3 pi's over 4. 3 pi over 4 plus pi over 4 is 4 pi's over 4, which is pi. And then finally 5 pi's over 4. Over here with our y values, we're going to add 2. So -2 plus 2 is 0. 0 plus 2 is 2. 2 plus 2 is 4. 0 plus 2 is 2. -2 plus 2 is 0. This final set of ordered pairs are going to be the ordered pairs that I'm going to plot. when it comes to my scale is going to go by pi's over 4. And since I only need to go up to 5 pi's over 4, this tells me that I can use the solid tick marks or dashes on the x-axis to create my scale. So this is going to be pi over 4, pi over 2, 3 pi over 4, pi, and then finally 5 pi's over 4. And I'm just going to stop with wherever my largest x value is on my table. On the negative x-axis, this is negative pi over 4, negative pi over 2, and negative 3 pi over 4. My y-axis, well, my minimum value is going to be 0, and my maximum value is going to be 4. So I label that as well. So now I'm going to start by plotting my points. I'm going to go with pi over 4, 0. Pi over 2 goes up to 2. 3 pi over 4 goes up to 4. Pi goes to 2. And 5 pi's over 4 goes to 0. And what I have just graphed here is one full cycle of cosine. And now I need to continue with this pattern both to the left and to the right of my axes, and that's going to show me that you understand how to make or show all of that this graph is periodic. So my next point is going to be at 2. Up here at 4 is the next point, back to 2, and then down back at 0, and I would anticipate that my next point would go back to 2. So I'm going to connect these points with a smooth curve, and that is one side of my graph. So now I'm going to continue with this pattern on the other side. So I'm not going to go down, I'm going to go up to 2, then my next point will be up to 4, then back to 2, back to 0, and I anticipate that my next point will go up to 2. So I always want to make sure that I'm putting in the correct and appropriate end behavior. Connecting all of my points, here is my final graph. All right, let's do that one more time. This time around, we're going to be working with a sine function. So I have example number 4. And in example number 4, I'm going to identify that my a value is -2, my b value is 1/2, my h value is 4 pi, and my k value is 0. So my amplitude is the absolute value of -2, which is +2. My period, this time it's going to be a little bit different. This is 2 pi divided by 1/2. So to write this out is really just 2 pi divided by a fraction of 1/2. And we know that to divide fractions, we need to multiply by the reciprocal. So this is equivalent to 2 pi times 2 over 1. 2 times 2 is 4 pi. So my period this time is 4 pi. My midline is at y equals 0, and I'm going to graph that right away so that I don't forget. Now, I'm going to identify the 5 key points of y is equal to -2 times the sine of 1/2 x. Notice that I write this equation without h and k. Then I need to come up with my table of values, and they are going to be based on the original starting point of sine, which sine always starts at 0, 0. And then my x values will be 1/4 times 4 pi, and that's essentially 4 divided by 4, which is pi. So this tells me I'm going in increments of pi. So this is 0, pi, the next one will be 2 pi, this will be 3 pi, and finally 4 pi. And remember that that last x value should always be equivalent to your period. If you want, you can go 1/4 times 4 pi, 1/2 times 4 pi, 3/4 times 4 pi, and 1 times 4 pi, and you should end up with the exact same values. Sometimes it's easier to go with the 1/4, 1/2, 3/4, and 1. Other times it's easier just to go with adding increments or adding whatever the second x value is to the over and over again until you come up with all of those values. It's whatever makes the most sense for you. Our translation vector this time is going to be 4 pi, comma 0. And I'm going to add 4 pi each time simply because my h value is positive. So now I'm going to add, so I have 0 plus 4 pi is 4 pi. Pi plus 4 pi, that's 5 pi. And I'm just increasing each value by another pi. So this will be 6 pi, 7 pi, and finally 8 pi. So all I did here was I added 4 pi to each x value. When it comes to the y values, I don't have to do anything because I did not have a vertical shift. And I forgot to put in my y values. Oh my goodness. So because my a value is negative, I'm going to just start at 0. And instead of going 0 up, I'm going to go 0 down. 0 down to negative 2. Back to 0, up to 2, back to 0. And because there is no vertical shift, all of these y values will remain the same. 0, negative 2, 0, 2, and 0. And this last set of ordered pairs is what I'm going to plot. But my first value is not going to be 4 pi. Like we've talked about before, it's all about what that first x value is of the first table, and that is what your scale is going to go by. So we're going to go by pi's. So I believe I'm going to count just to make sure I don't have to go by every individual little line. I'm going to count my thick lines to make sure I can go all the way up to 8 pi. So this would be pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi. It fits. Voila. That tells me I'm going to go by pi's. So here is pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, and finally 8 pi. And if you want to finish it off and call it 9 pi, that's good. If you don't want to, that's fine too. And just make sure that whatever your biggest x value is of your table, it is represented on this graph. On the other side, we have negative pi, negative 2 pi, and negative 3 pi. With respect to max and min, my maximum value is a 2, my minimum value is negative 2, and I'm comfortable just working with going by 1, so I'll make this 2, and this will be negative 2. And now I'm going to plot just my final key points, and then I'll expand it from there. So I'm going to start with 4 pi 0, so here is 4 pi 0. Here is 5 pi going down to negative 2. Then 6 pi 0, 7 pi is going up to 2, and then 8 pi 0. And I'm going to draw just one quick smooth wave, and this is one full cycle of sine. And I'm going to continue with this cycle to the left and to the right. So I anticipate that my next point after 0 is going to go down to negative 2. And then after that, it will go up to 0. So it's always imperative that I show my appropriate end behavior, anticipating where the next point is going to be. The previous, so going back here, my point that would come after negative 2, 0 would be the number 2. Then back to 0, down to negative 2, then back to 0, up to 2, then back to 0, and down here at negative 2. So all I did was continue with the pattern, and I'm going to draw a smooth curve going through these points. Please make sure that these points, that this curve is curvy and not zigzaggy. Make sure it's not, they look like a bunch of parabolas or parabolic shapes coming together instead of absolute values with appropriate end behavior. All right, the next page has a team and a solo, and we will discuss this the next time that I see you in class. So I strongly encourage that you complete the next page on your own and have this ready for class. So now we're going to flip to the very last page, and what I want to discuss with you guys is how we can create or write functions based on key information. So looking at example number 5, it reads, write a sine function for a graph that has an amplitude of 4 and a period of 6. So what's cool is that I know that based on the fact that it says that my amplitude is 4, my A value has to be 4. But be careful. Period of 6 is not the B value. We use the b value to help us to find period, but period is not the same as our b value. Remember that period is 2 pi divided by b, and they're saying that this is equal to 6. So how do you find what your b value is? Well, we set up a proportion. So I'm going to say 2 pi divided by b is equal to 6, and I'm going to make that 6 over 1, and I'm going to use cross product. By doing that, we end up with 2 pi is equal to 6 times b. I want to solve for b, so I'm going to divide both sides by 6, and 2 over 6 simplifies to 1/3. So that tells me that b is equal to pi over 3. So now that I have an a value and I have a b value, I can write my equation. And my equation is going to be y equals 4 times the sine of pi over 3 times x. Now, if you want, you can insert an h and a k. This is not, it's not going to prevent you from doing that. If you wanted to make your a value negative, it would still follow the same parameters as what we see here in example number 5. In example number 6, it's asking you to write a cosine function for a graph that has an amplitude of 1/3, a period of 2. It's been reflected in the line y equals -1. Okay, so based on this information, I know that my a value will be a 1/3, but because it says the word reflected, that tells me that my a value has to be negative. Then my period is 2. So that, remember that that's not your b value. Period is 2 pi divided by b, and that's going to be equal to the number 2. And I'm going to make that 2 over 1, and I'm going to use cross product to help me define what b is. So that's 2b is equal to 2 pi, and I'll divide both sides by 2 to find that b is equal to pi. The last clue that I have is that this has been reflected in the line y equals 1, and I have no information about h. So you can make h whatever you want. So I'm going to make h 0, and I'll make my k value -1, because remember that the k value is always your horizontal line that's our axis. So now putting all of these pieces together of a, b, h, and k, I'm going to write my cosine equation as y equals -1/3 times the cosine of my b value, which is pi. My h value is 0, so I can do x minus 0, or I can just call it x, and then -1. Our final example is example number 7, and this is asking us to write an equation of the described graph, and this time around we have y is equal to -5 times the sine of 5x, and this one has been translated down 4 units and left pi units. So down 4 units means that our k value has to be -4, and left h units means that our h value has to be -pi. So when we write our equation, that's y equals -5 times the sine of 5 times x minus -pi minus 4. Negative negative makes a positive, so my answer is y equals -5 times the sine of 5 times x plus pi minus 4. And finally, for letter B, we have the graph of y equals 1/4 times the cosine of 2x is reflected across the x-axis and translated up 3 units. So reflected means that I will have a negative a value, and translated up 3 units means that my k value will be equal to the number 3. So when I write my equation, this is y equals -1/4 times the cosine. And since I have no information about h, I can insert something. You can let h equal something, but you don't have to. So I'm probably just going to keep it just 2x, and then I'll just add 3 at the end. And that's our equation, as well as the end of this lesson. If you have any questions over anything I talked about in this lesson, please feel free to email me. Otherwise, I hope you have a wonderful day.